In continuation of our series for parents on graphing lines, what we're going to do today is take a look at some pictures of lines and count the slope based on the graph that we see. So I'm going to do a screen share. Here we go. All right, so on this graph paper, I'm taking a look right over here. Got to turn on annotate. All right, I'm looking at this graph right over here. And I wrote up at the top y equals mx plus b. This is the first form of a line that students learn. And as we saw on a previous video, the m here is used for the slope, and that's what we're focusing on for this part. So what I'm going to do is either count up and to the right or down and to the right. Trust me on this, your life will be so much easier if you just always go to the right. When you go up and to the right, you have a positive slope. And when you go down and to the right, you have a negative slope. So let's take a look at the first one here. I'm counting from this dot to the next one. I'm counting up 1, 2, 3. That's the rise. And then over to the right, 1. That's the run. Rise over run. So we go up first. We have to stand up before we can walk, before we can go to the right, up and to the right or down and to the right. The teacher will prefer to see this number written as just 3. As I like to say, 3 over 1 is correct, but it's not scholarly, so we prefer to see this one. In the first picture, I had a whole bunch of dots. It doesn't matter which combination you use. It will always be the same, 1, 2, 3 over 1, 1, 2, 3 over 1. On this next picture, there are only 2 points. And to make a line, you only need 2 points. So this is totally okay. So again, I'm going to start at the bottom and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Better write that down. And to the right, 1, 2, 3, 4, 10 over 4. Okay, the slope is 10 over 4. In this case, we have to reduce. Slope is always written in lowest terms, even in calculus, you have to reduce it. So 5 over 2 would be our correct answer for the slope. If you want to have a variable in front, we're going to use the m because m is our variable for slope. All right, so let's go look at the ones on the bottom there. Let me scroll down. Oh, I guess I have to stop my share in order to scroll down. Just one moment, please. Okay, back to Zoom we go. Share my screen, back to the template. Okay, so in the next picture, I've chosen, and I'm over here on the, oh, come on now, annotate. Over here on the left. I chose this format because this is an example of a line with a negative slope. It's a negative slope because we have to go down 1, 2, 3, 4 in order to go to the right over 1. If you're not sure, you can double check with the next set of points. 1, 2, 3, 4, down 4, over 1. If you were asked to put one more point on this picture, you would use the slope to do that. You would go down 1, 2, 3, 4, and over 1, and then you could connect the dots, and that would be your line. All right. Finally, we have an example here that really gets students flustered. It shouldn't, but it's what happens when the slope is 1 and it goes through the origin. So first, let me demonstrate that the slope is 1. I go up 1 over 1, up 1 over 1, 1 over 1 is 1, so the slope really is 1. But the other thing that makes this picture kind of interesting is that we have this y-intercept of the origin. Okay, the y-intercept is where the line crosses the y-axis. If we go back to the example here on the left, the y-intercept is right here, it would be 7. The complete equation for this line would be y equals negative 4x plus 7. But in this picture, the y-intercept is 0. So it's as if we're writing the slope formula like this: y equals 1x plus 0. Now, again, this is correct, but it is not scholarly, and the teacher will prefer to see it written this way: y equals x. That would be the final answer. So if you see an equation that says y equals x, that means it's a line with slope 1 and a y-intercept of 0. All right, folks, I hope that helps, and I will see you on the next video.